let's begin tonight's session by welcoming our first speaker, Vladimir Khazin. Vlad is a solutions and DevOps architect. He has been introducing and implementing microservices-based solutions to address expensive to scale, hard to troubleshoot, and risky to upgrade internet-facing applications. Tonight, Vlad is going to be talking about the benefits of microservices architecture to the enterprise. Let's welcome Vlad.
Good morning, everyone, or at least it will be when we're done. Thank you for joining us, and thank you for organizing the event. I will talk about the introduction and the challenges that I've personally faced introducing microservices in established and not so established enterprises. This talk may not be necessarily as technical as you would expect. I will talk kind of on a mixture between the technology and the humans. We will talk about the past experiences and challenges and how it reflects on your specific environment. You will figure out. What I will talk about, I will compare microservices to alternative architectural styles, and there's a lot of confusion there. You probably already heard that microservices frequently compared to SAW. I have a few more examples to talk about. Then we will reflect on the setbacks and emotional or technical setbacks that I run through 4 enterprises by now, introducing and implementing microservices. And finally, I will give out a few tips that may help in your enterprises introducing the microservices and implementing them. So the first of all is the benefits of microservices starts from what they are for. In a nutshell, the image borrowed from the AWS website. The microservices is when you take in an existing application that is tends to be tightly coupled, for sure using a lot of in-memory reference to components, libraries, and the like. You break it down and you establish the boundaries that communicate one to another, usually using an HTTP or HTTPS protocol. Some other speakers will talk also about the messaging approach to implementing microservices, but the most typical examples that you will come across today when you talk about microservices, there is an HTTP endpoint and one microservice calls another microservice service in a matter of a request and response. And the questions that will pop in your mind is why to bother if we already have an application and it's already working as expected? Why bother to go down this road? So there's a microservices.io website which is littered with the references. I'm trying to keep it as short as possible, and I'm going to focus on the most important one. So the first important one is when you're dealing with a complex application, it's just a matter of time when you're standing in front of a failing application and you're wondering what's going on. In my first company, when we ended up, we have a SAW-based application solution. It was running in production, the traffic was going up, the CPU utilization was going up, memory utilization was going up, performance going down, surprisingly, and the group of developers is standing in front of a monitors like, where's the problem? So that's how we ended up where I first started questioning, is that normal? And I reflected back on my past experience. If it was the first time, I would say we're crappy developers, we build a bad code. If it would be the 15th time that I find myself in the same situation, I started questioning myself as an architect whether I'm going down the right path. So that was the first. Promotes testabilities. What happens is when we build application, I grew in a time when unit tests were unnecessary at the very least, and there are probably still today a tendency to leave the testing for last. When we are done with absolutely everything else, then we will test our application. The microservices complicates the problem of not having unit tests. When you have 2 components talking one to another and you did not test component A before it got called from component B, that's great. You will figure it out because there's an A and there's a B. When you get from A to ZZ, the things get more complicated and you did not test every individual component. Now you have a bigger problem to solve. So testability is kind of not a benefit of a microservices per se. It's just encouraging people to go down the route of an input-output mindset, test result type of input, output, request, respond, what do I want to get, what did I get in response, and how do I make sure it all goes on. Reduce cost and risk of deployments. This is the the nightmare of every organization. One of the organization in the past reflection, the deployment would take an average 72 hours. Because there's something that you do automatically, something that you do manually. Invariably, you end up with something failing and you need to deal with it. And the joke was an organization that majority of the deployment people, by the end of the deployment night, take a taxi and go straight to emergency room. 72 hours troubleshooting a problem is not necessarily the easiest task. How microservices help that? Your deployments get smaller. Each individual microservices is a lot less risky to deploy, to roll back, and to figure out when it's failing. If you're not going to be standing up in a situation, I found myself more than necessary, standing in front of application, high CPU, which one? Which module is giving me the problem? Next one is the problem of over-centralization. What happens is in organization, there's some speakers, and I feel bad for them right now, there's a governance. In organization, there is a great leaning toward, let's establish a great governance. Let's select the right tool. Let's speak the right language. Congratulations, you just updated to Java 8. That was a major undertaking, and by the moment you're done, you need to start over because there's a Java 10 last time I checked, and probably Java 11 and 12 are coming next. So one of the microservices advantages is you can break down the complexity to make teams more autonomous. This team is still on Java 6, and they're happy about it. Go for it. This team really fallen in love with Golang. Go for it. As long as you can establish communication between components over standard protocols, enjoy. Roll forward. And if you think it's a bad idea, I will reflect on my past experience and the country I was born in. If you think that decentralization is not a great thing, look no further than China and Russia. They centralized everything. Worked great. Long-term commitment. How many of you are working with applications that were built 5 years ago, 10 years ago, 15 years ago? How about 50 years ago? Well, financial institutions, and a few of you work at bank or have worked with the banks, you know there's no way to roll off a mainframe. There's still a need for RPG developers. There's going to be continuous need for COBOL developers. It's not going to go anywhere. The reason being is too much investment. We cannot break it down. We cannot build a new functionality inside existing system. Too risky, too expensive. Microservices come from a different approach and say there is no such thing as legacy. There are two types of things. Those that works and we keep them running, and those that require an update or replacement. The smaller your unit of replacement, the easier your life. The Netflix motto was a microservice should be able to rebuild in 2 weeks. Not number of lines of code, not language, not the number of time it takes to rebuild. Moving along, fault isolation. If we were to build our application not as a monolithic but as an individual, we would have one microservice that consumes all the memory, and we would be able to analyze it much easier than having a monolithic application. Moving on. History. Microservices were not introduced when we think they were. They first mentioned in 2005. Obviously, every sane person have ignored them at the time because that would be insane in 2005 to talk about microservices. The official final mentioning of a microservices is 2011. There was events conference, and finally there's a microservices.io registered in 2014. You can read a lot about the history, but that's where it's all started. Netflix published a blog in 2015. Why there are those pictures? This is a nightmare that people are scared of, and they demonstrated. Every dot on these two diagrams, one from Amazon and one from Netflix, represents a microservices. The total number of microservices at the time I was reading about at Netflix, and it was 2015, was 700. And I was thinking to myself, well, Netflix model is not overly complicated. You log in, you search for a video, and you stream it, right? How did you end up with 700 microservices? So if I'm reflecting on the more established enterprises, let's say an RBC decides to move to microservices, what's the total number is going to be? I have no idea. But the point of this slide is, in 2016, people started saying, well, that's a nightmare. My answer to that, well, you already have this nightmare. It's just hidden. You already have component modules, classes, libraries. They already calling each other. With microservices, you can visualize it. Without microservices, it's behind. It's somewhere there. It's somebody, nobody cares. It's there. I don't see it. out of sight, out of mind. So this is not a problem on its side, it's just a visualization of problem we already have. In 2018, an article came out, somebody's talking at length of what the great benefits they reaped off from going away from microservices back to monolith. What I'm trying to reflect here, people will have different opinions, people will have different approaches. Microservices will not solve the problem of aging. It's going to solve some problems in IT, it's going to introduce new problems. There are benefits, costs, and benefits. Alternatives by confusion. I select this term to demonstrate that microservices are often confused with different architectural approaches and communication patterns in the distribution between applications. The problem remains to be we have multiple applications that need to talk to each other over the network more often than not. The time of having monolithic application running in a single memory space is probably safe to say by now is gone. So the confusion of microservices, how they fit in to solve the same problem. Service-oriented architecture, if you've been long enough in an industry, about 10 years ago was believed the best things that ever happened until large vendors, well, let's name Oracle, not to single it out, but Oracle has introduced enterprise service bus software. Expensive, costly, difficult. So right now when you say SOA, in most enterprises people start rolling their eyes, especially if they're below age of 40. And people who are live long enough and they say, well, yeah, you're going to just end up with exactly the same problem as SOA has. RPC, remote procedures calls, are a lot older than SOA and a lot older than microservices. The problem remains the same, exchanging information between multiple parties. Google moved forward and they introduced gRPC, a kind of a model RPC, which allows us again to communicate over distance, over network, over some sort of a connectivity. Mini services, somebody came forward with a suggestion, well, microservices are too small. Let's go somewhere in between a SOA and a monolith and let's introduce mini services. That's an approach. There's a more historical reference today to .NET remoting and Java remote method invocation. Very exciting technologies if you work with it. If you're older, you may recall there was a distributed component object model, same problem, how we communicate two components across distance. Corba, if you're really ancient, you probably touched it, you know how much fun it was. EDI, you probably retired by now, but there was a first protocol I came across, electronic data interchange, when two systems needs to exchange binary data. It was unreadable by humans, it was difficult to troubleshoot. I did not like it. And before that, that was Microsoft, sorry. It was an IBM technology in the mainframe days, how to exchange data across machine on the network. Enterprises are not perfect entities. There are fires every so often, probably an average every hour. We have multiple deployments. Every department believes that they need to live in isolation. Every department sooner or later comes, oh, we need to compete with another department. We have a Conway law, that's a beautiful one. Conway law dictates that the software design in an organization will invariably reflect on organizational communication patterns. Where are you going with microservices to that? We're already having troubles to communicate between departments and we just want to explode it by having a lot of microservices. Technical debt, we all take shortcuts. Under the pressure, under the business pressure, technical pressure, we do stuff that we'd rather not have done, but we have done it. And that keeps building to a technical debt and you come in and you say, oh, let's break down technical debt to microservices. That's going to be an interesting journey. Software decay. Over time, great design decision meet a reality of implementation. Software gets worse over time. It doesn't mean that if software is not being changed, it's getting worse. It's when software is getting worse over time, it's becoming worse and worse and worse in terms of implementation. Not invented here syndrome. If you work in a large organization, you probably come across people who have been there for a long time, and if the invention is not coming from within an organization, we don't want it. One of the reflections I heard, a new shiny thing need not apply. We know better that in our environment what works, what does not work. So microservices have not been, or probably have not been invented in your organization. Therefore, you may face this like, we don't need that. That's not how we do it here. Again, comes from the a human nature of following on what we know works and ignoring what otherwise may be happening around us. Nobody gonna eat my cheese. It's a reflection on the book named Who Moved My Cheese or Who Ate My Cheese. The book talks about an environment where mice live and they're eating from a cheese. And with time, the cheese amount of cheese available keeps shrinking. There are two groups of mice. Those that ignore it because cheese was always there. It's not gonna disappear. We always ate from the same cheese. It's not gonna change. And some chicken little that is running around and saying the cheese is running out. We need to change the way we live. Reflection on our software, just because something worked for the last 30 years is not a guarantee it's going to move and work for the next 30 years. Somehow, as humans, we tend to avoid it. Moving on. Implementing microservices in different organizations. First, push back, make them bigger. In theory, it all makes sense, but we cannot have a 200 microservices. Vlad is being stupid here and saying, yeah, you're not going to have 200 services. You're going to have 3,000 microservices. Discussions usually goes into a direction, well, we can't support that. Make sure they're not too granular. There are best practices in microservices. What defines a microservices? We're the binary of the microservice, and they're supposed to be cohesive, meaning that they need to reflect on a business domain or in technical domain. What happens to data integrity in a database? That's one of my favorite ones. I don't know how to tell it. The database integrity is already gone. You probably have more than one database in your organization, and there's probably not a database integrity across different databases. So as strong as this argument may sound, you may already have crossed this bridge. System of record is another trouble. If you live in a large organization, every organization decides this is going to be a system record for this data. And then over time it changes. And then we ship it. And then we introduce another system. One of the companies I worked in, we had 3 billing systems for the same line of business because things kept moving. So again, maybe we already crossed this bridge. How to trace errors? Well, how do you trace errors today in monolith? If you don't have logs and the problem has occurred, how do you know what's going on? Do you attach debugger to a production system and you go line by line to find out where's the problem? Don't laugh. Sometimes I did, because that was the only way to troubleshoot. At showme.com, one of the companies I work at, sinfully, I launched a SQL Server profile in a production system to catch all the requests that go to the database, no less than to the database, to see which SQL statement generates the problem that end user is not able to log in. Great approach. Moving along. In other organizations, we get the idea, we're just not ready. What do you mean we're not ready? Well, we don't have the facilities, we don't have a skill set, we don't have the automation, we're not ready to go down this direction. Well, when you will be ready? By the time that microservices will be irrelevant and something else will come across, reflecting on working at one insurance company, coming on board in 2005, launching a laptop, a Windows logo comes up, it's like, I don't recall this Windows logo. Oh, Windows 2000, fantastic. And sure, that you can go this way. There's not a single female programmer here, so don't take it as a sexist. In the Xiaomi, one of the developers, Darian Torres, you may come across his reference, great guy. We were joking about how poor our code is organized because we don't have unit test. We change the code, oh, we have no idea it's going to actually work until we deploy it to an environment and the QA tester starts touching it. That's fantastic, but it's not very sustainable. So if you don't have unit test, your life with microservices will be worse. You know? Well, in-memory function calls are faster, and C++ is faster, and Java is better, and the list goes on. Why you cannot do any different than the way we do it today? Communication over networks are slower, but again, this breach is behind us. We no more building systems that runs on one computer. We're already in a highly distributed world, and communication over a network is a necessity. It's a question how you do it. HTTP is an efficient protocol, for sure, but there are other ways to bind microservices if it's a problem. But before you jump to a conclusion, that's the biggest problem you have to resolve. Have you actually tested this theory? In a couple of places I've been, we're never going to do that. We're not going to do it because it's going to slow down our architecture and entire solution. Then we test it and we find out, well, actually our bottleneck is connecting to the database, not connecting between microservices. That theory went immediately down the drain. We don't need a polyglot programming. One of the benefits of microservices, you can build services using different languages. And yet, so often in an organization, we're a Java shop, we don't need any polyglot solution. We already crossed this long time ago. We are Java, preferably Java 6. Well, you can do that. It's just you're not evolving, you're staying still. We're not Google, Amazon, or Apple. That's another argument I loved in one of the enterprises. I was shocked to hear it's like, is it that an indication that we're better? I don't know. These are the most progressive companies, and they decided they want to use microservices, and they do want to embrace a polyglot solution. So hey, let's not go there. Security. Whenever you talk about endpoints, somewhere a security guide comes forward and says that's not secure. We need to secure it. There are two types of security. There's a network security and there's application security. If you go a network security, you have a bigger problem. This problem called network traffic sniffing. Highly available, highly easy to implement in all major enterprises. So that's not the problem that you go in microservices. You have a bigger problem related to security. Good enough? Are we ready? Well, is it easy to implement microservices? Oh yeah, absolutely. The reason is, why would you do it? First, do you care about supporting your business users? The sole purpose of our existence is to support business cases. Yeah, we know, we cherish our accomplishment as the software developers and architects. We think that business runs around us, but we're just carpenters of modern days. We build a technical solution for business problems. Microservices help you to become more agile, to release solutions faster, and to upgrade them easier. That's why it's number one. Do you care about how long it takes to deploy? 72 hours sounds all right. Sure, if it's okay, it's okay. Do you care about maintaining environments? What organizations do you know that was able to actually purchase a double production environment? It's usually expensive. You heard? That's literally first time I hear. Every time I hear, oh, we have an environment that's great up to here. But here you're hitting a mainframe. No, we don't have a second mainframe. That's where you stop. Or here we hit an external partner, and that's it. We cannot go anywhere there. So microservices adds a potential for agility in deployment and reducing cost of maintenance. Anybody likes to maintain legacy software? The bad news are, every software is a legacy software. The moment the compilation has finished, it is a legacy software. Organizational silos and task force, everybody is aligned, everybody knows what they're doing. No, that's rarely the case. So microservices help to organize work in a smaller unit with a clear defined boundaries, input, output type of thinking. I don't care how you do your stuff. I'm going to send you this, you're going to return me that. Software architecture does not stay the same. It changes way too often. The same goes for software architecture. It's the piece that is most difficult to change. Well, microservices break this pattern. With microservices, it's easy to change architecture because now every microservice has its own architecture. And you're only exposed to bad decision, which I inevitably made, only within a boundary of microservice. Good enough? We don't have to change. In most cases, most enterprises feel very comfortable where they are. The only problem that you may be facing is there's a slight change of pace. This is the 4,500 years from the moment the abacus was invented until the web application. And here's the last 15 years. The last icon on the slide is 2015, which clearly indicates that Vlad has missed the last 4 years worth of development. There must have something happen worth mentioning in the last 4 years I did not capture. But what I have captured is web applications jumped to SOA. From SOA we went to microservices. From microservices we moved on to serverless. We got Kubernetes. We get to API economy. The race never stops. So where do you choose to adopt or not adopt microservices? It's only a question, will you find yourself on this list? You, maybe your organization, or maybe you as an individual. Thinking in terms of a next job interview. Are you going to be okay saying that our organization decided that SOA is as far as we ever need to evolve? If you want to be in the same position, if you find out like Oshawa, union workers today, when GMC is shutting down And unfortunately, there's no next job for them because the automotive sector is not doing great. Do you want to be in this position? I think that's it.